Welcome to the solution to integration 1. So, we've got this problem here and we have to decide, is it an integration by parts problem, is it an integration by substitution, partial fractions, or is it a standard pattern? And of course, to confuse matters a little bit, more than one of these techniques might work on it. So the first thing I'm going to do is just to change the form of it. I'm going to stick it in index form. So I've got x times 1 plus x to the power of a half with respect to x. Now, some people I have seen have been tempted to multiply these brackets out. You can't, because it's a power of a half. You can't multiply it out. You could use the binomial expansion, but it would go on forever, so that wouldn't be much use. First clue is the thing in the bracket. If I differentiate it, do I get this? And the answer is no. If you differentiate x, you don't get x, you get a constant. So standard pattern won't be a lot of use here. This is looking rather like a substitution problem, so I'm going to just have a shot at saying let u equal 1 plus x. So if you haven't got this far and you want to have a shot at it, press pause and try it yourself before you watch on. Okay, so du by dx would be equal to 1, and let's see where that takes us. So we have, now what are we going to do with x? I think I'm going to rearrange this for x, so x is equal to u minus 1. So I can replace the x with u minus 1, and then I've got 1 plus x, that is u to the power of a half, and if I rearrange this I get du equals 1 times dx, which means I can just switch to dx for a du. And what this has done is it's basically allowed me to multiply it out, because I've now got the brackets is to the power 1. So if I can multiply that u by that u, then I get u to the power of 3 over 2 minus 1 times u to the power of a half with respect to u. And that, of course, is a fairly trivial integral. So I add 1 to the power, so it becomes 5 halves, and divide by 5 over 2. And then I subtract u to the power of 3 halves, and I divide by my new power, and don't forget the constant. That simplifies to 2u to the 5 halves over 5 minus 2u to the 3 halves over 3 plus c. And since this is a indefinite integral, there's no limits on it, I'm going to leave my answer in terms of x, which means I need to put the x back in. If I was putting limits in, I'd have just turned the limits into terms of u and substituted. So to finish off, I've got 2/5 of u, which is 1 plus x to the 5 over 2, minus 2/3 of 1 plus x to the 3 over 2 plus c. And there we go. Okay, the second problem. So the same thing really. Is it a partial fractions problem? Now, I suppose you could think this is partial fractions. The trouble is the bottom doesn't factorise. It looks like the difference of two squares, but it's not, because it's a plus, not a minus. So it's not that. You could probably do this as a substitution, but the key thing here is to notice that if that is fx on the bottom, then on the top what you have is the first derivative, because if you differentiate an x squared, you get an x. You get a 2x, but you get the idea. You get from a power 2 goes down to a power of 1. So I'm just going to try a solution. I'm going to try y equals ln of x squared plus 4. And if I try that, if I differentiate that, dy by dx, I get the differential of what's in the brackets, which is 2x, times the differential of the ln, which is of course 1 over x squared plus 4, which gives me 2x over x squared plus 4. And then I compare that to what I've got here, and I can see it's very similar. In fact, this is half the size of that because it's got the 2 in front of it. Therefore, the integral of x over x squared plus 4 with respect to x is not this, it's half of this. And of course, don't forget the plus c. Okay, what have we got here? Well, not a very nice looking thing at first. I suppose you could say it's not partial fractions because it's not got a linear factor on the bottom. It's possibly a substitution, doesn't look like a substitution really. It leaves you with sort of standard patterns, and it leaves you with parts, and this is of course what this is, it's an integration by parts. So how can we see that? Well, you need to know that sine squared x is cosec. 1 over sine squared x is cosec squared x. And that's the key thing. So you might like to have a go at it now yourself if you haven't. If not, here we go. So u is our x term. You usually make the x term our u, unless of course there's an ln in it. And then we have the dv by dx, which is cosec squared x. And then we can work out the u by dx, which is happily 1, and v, and you'll need to learn your standard results for this, it's minus cot x. So now I can substitute into the formula. So it's uv, so it's minus x cot x minus v du, so minus cot x, and du is 1 with respect to x. So that is minus x cot x plus the integral of cot x with respect to x, and again you'll need to know your standard results. If you don't, start learning them now. Definitely a good time. And it's going to be cot x goes to ln of sine x, and then you've got your plus c on the end. Okay, and this one here is fairly obviously the partial fractions one. So let's start out with the partial fractions. So we'll start out with 3x plus 5 all over x plus 1 times x plus 2 equals a over x plus 1 plus b over x plus 2. Therefore 3x plus 5 equals a times x plus 2 plus b times x plus 1. And now we try some values in. So if we stick x equal to negative 1 in first, then this bit here, 3x plus 5 becomes 2, and then a times 1 plus b is of course, this is 0 because of the minus 1, so that tells us that a equals 2. And then if we stick in x equaling negative 2, then we end up with negative 1 on this side. The a of course vanishes, and we're left with minus b, which of course means that b equals 1. So now we can get on with our integral. So this integral is equal to the integral of a, which is 2 over x plus 1, plus b, which is 1 over x plus 2 with respect to x. And these are both ln's, pardon me, so 2 ln of x plus 1 plus ln of x plus 2 plus c. And it's worth noting that the reason that there's nothing in front of the ln is because these are both plain x's, and there's no negative and there's no coefficient in front of them. And there we go. Hope that went well for you.